Alright, so this video is going to be a quick little session on how to find end behavior. And what end behavior is literally exactly what it sounds like. What is the behavior at the ends of the graph? And what I mean by the ends is what's it doing on the right hand side and what's it doing on the left hand side. Okay? We don't really care what's happening in the middle, it's just what's happening on the far right and the far left. Okay, so the easiest way I can do that, show you a few graphs. Alright, so I do want to point this out real quick. I've shown this to remind you. The x-axis, okay, runs this way, left and right. Clearly these are positive values over here on the right, while these are negatives. The y-axis runs up and down. Positive is up, negative is down. Okay, so that's why I find this so easy. If you notice, if I asked you, as x approaches the positive side, positive infinity, that means the x is going positive, that's the right hand side. And I'm going to ask you, what is f of x or y doing? Well, clearly if you look at your graph, it is going up. So all you have to write is the fact that it's going up towards positive infinity. Alright? Now, this part on this particular problem is a little bit difficult, as x goes to negative infinity. So that means over here. Now, if you notice, we've already talked about radicals. This thing is not even going to the left, so we wouldn't even have to write anything for this. There's no end behavior on the left-hand side. Okay, so another one just like that. Okay, again, this part means as x approaches positive infinity, that means you are approaching the right side. X is positive. So if I look at my graph, it is going up. Positive infinity again. This part means the left hand side because x is negative, and clearly it's not going to the left, so again, no end behavior on the left side. Alright, so if you look at your ends on this graph, very simple. Both of these are going up. Alright, so because they're both going up, both y values must be going towards positive infinity. Alright, and this is an example of a positive even polynomial, because both arms are together and they're both going up, positive even. Okay, here's an example of a positive odd. So, just to get started, as x goes to the positive side, so again, x is positive, I want you to think the right side. What's your y doing? Well, it's going up, so this would have to be positive infinity. Now here, as x is going to negative infinity, well, that means that x is over here, the negative side, and it's going down, so we're going to say that's negative infinity. Okay, that's all there is to this. Alright, again, these even graphs, which this is a negative even, they're extremely simple. Both your arms are down, which means both of these are going towards negative infinity. Alright, here's another problem. Okay, back to these rationals. They're a little bit more tricky. Alright, as x approaches positive infinity, well again, that means what you have, okay, you have, talking about this side of your graph, the right. So as this thing keeps going on in this direction, what it's going to do is get closer and closer to this dotted horizontal line. We call it a horizontal asymptote. And it's actually getting closer and closer to the y value 1. Alright, the same exact thing could be said over here to the left. As it goes to the left, it's also getting closer and closer to 1. And that's why we spent so much time trying to figure out how to find these horizontal asymptotes. Alright, one more. If you know what your horizontal asymptote is, you can find this in behavioral rationals really easy. So over here on the right side, it's getting closer and closer to the x-axis, which is the y value 0. So when you think about it, the right side is when x is, okay, positive. So we're going to put 0. And the same thing is true on the other side of the graph. Over here when it's negative, x value is negative, you're also getting closer and closer to 0. Alright, so when you hear end behavior, think about the left and right side of your graph. And just remember, x is negative on the left and x is positive on the right. That's all there is to it.